All right, so we're talking about solutions and ion dipole forces. So that brings us to the topic of electrolytes. So what is an electrolyte, right? If you've seen a Gatorade commercial, you've seen they've made, billions of dollars off of selling electrolytes. So what are they? It's pretty simple. An electrolyte is just something that forms an ion when dissolved in water. And so if you have no ions being formed, you have what's known as a non-electrolyte. So this is an example of this would be sugar. So sugar is C12H22O11. So you have it as a solid, and then you toss it into some water to dissolve it. Well, when it dissolves in the water, it will not form ions. So it will still stay as molecules of this C12H22O11. And so there's no ions being formed here, so it's a non-electrolyte. It still dissolves, it's just not an electrolyte. So we have non-electrolytes. Next up, we have strong electrolytes. And so strong electrolytes are where you have all of your dissolved particles make ions. So if you put 10 particles in, you get 10 ions, and so on and so forth. So all dissolved particles make ions. And then we have weak electrolytes. In weak electrolytes, some of your dissolved particles form ions, some don't. So we'll just say some, and then we'll copy up the rest, right? Dissolved particles make ions, right? So only some of them. And so why are they called electrolytes? Well, we can measure how strong an electrolyte is by whether they conduct electricity. So electricity is the movement of charge. And so in order to have electricity, you need to have charge that's able to move. And so if you have something that like ethanol, which is a non-electrolyte, you have no charge to move, so electricity cannot flow. So you see the light bulb is not turned on. Then we have something like Kcl Potassium Chloride. This is a strong electrolyte, so it completely dissociates. And as you can see in this little picture, that means that the charge can move back and forth. And so we can conduct electricity, so our light bulb is glowing brightly. And then we have something like acetic acid. This is what's known as a weak electrolyte. So some of them form ions, some of them don't. And so you can see our little light bulb only semi turns on. So the main type of electrolyte that you will see is ionic electrolytes. So in an ionic electrolytes, you have essentially ions that are being formed, and it's because an ionic compound is dissociating, right? So sodium chloride, if we dissolve it in some water, we'll end up with sodium plus and chloride minus, right? So you see the ions are coming directly from the ionic compound. This is what's known as dissociation. So when we say an ionic or solid dissolves, we say that the cations and ions separate or they dissociate. So dissociation, right? And this is very favored because of what we just previously learned with the ion dipole intermolecular forces, right? We have the positive charge, we have the negative charge, and we can form ion dipole forces, which are very favorable and thus more likely to dissolve. So here's just a picture of that. Right, so in this solution, we have some KF, some potassium fluoride. And if we zoom in on it, what you'll see are our ion dipole interactions. And so In a solution, we can take a look at the enthalpy of the solution. So that's delta H of solution. And as we said before, in order to make a solution, we must break up the solute-solute interactions. So this is a positive number, right? This is an endothermic process. We must also break up the solvent-solvent interactions. This is also a positive process. And then we get back out some solvent-solute intermolecular forces, and so this part is negative. You can take a deeper look into some of these numbers, right? Solute, if you're talking about an ionic compound, that's correlated to your lattice energy. So think about Born-Haber cycle from CHEM101. And so if this delta H of solution is overall positive, right? You have three numbers. If these end up being a positive number, it's endothermic. And so it feels cold, right? It takes more energy in than you get back out. And so this is how a cold pack works. So you break the little kind of barrier in there, and then you have a solution formed that is overall endothermic, and so it's absorbing energy from your hands and mixing. Again, why does a solution form even though it's endothermic? It's all because of entropy. And then obviously, if you have this delta H of solution being negative, then it's going to be exothermic, and it's going to feel hot. And so this is most solutes dissolving will actually feel hot. If you dissolve a bunch of salt in some water, and you probably won't be able to sense it with your hand, but it is actually getting a bit hotter.